Welcome back to part 10 of the Satisfactory tutorial. Now, in this part, I'm going to be doing first one tiny little bug fix for the actual materials, which I've kind of been ignoring up until now. How we set up that the materials just become transparentish blue when we're crafting or orange when we're deconstructing, and they should be reset after, but the thing is it's not working very well with the actual attach points. So we're going to be modifying that to fix that first. And then the next part of the video is going to be, or the next part, the whole of the video, except the first maybe 2-3 minutes, we'll be focusing on making energy. So that's the electric poles, the cables, and a basic power generator. So the first thing we want to do is we want to go and modify this material issue. So what I mean by that is currently if we add a conveyor here and we place it, the material changes back to this. But if we do with this, our actual splitter, for instance here, we have the arrows that are a different color, but the instant we place it, they become gray. Now they do have a direction, so it's still okay, but it shouldn't be like that, right? So to fix that, what we need to do, there's a few little things. First, we need to go into the player. Well, we need 3 things. We need the player to be open, because we're going to make a small change there in our actual spawn build here. And we're going to make an actual change here to expose a variable. So in our A build, because that's the base class that we use here, we get our A builds and we want to make a variable. Now this variable is going to be a boolean and it's going to be called already placed. And by default, I believe we'll leave it to true. So we want to compile and save and make sure it is exposed on spawn and instance editable and true. Now, once this is done, we want to go and look at our create build. So I believe it is here. And in create build, what we want to do is we want to get our set all materials, attach it here, and we want to get our MI hologram. Now, we don't want to check default because we want it to be hologram when we create it. And then we want to have a branch with our already placed. And what this does, right, is if the item is already placed, meaning that it is something like this, we're going to be resetting it back to default. Because if we don't do that, then all the objects that are already placed in the scene don't work, or at least they'll remain in that kind of hologram state, and we don't want that. So this will work, but it will also cause a problem now, and that is that all these arrows are now losing their color as well. And the reason for that is because in a building, we're doing the same thing, but our material function here doesn't take the actual attach points into account. So we need to open our a buildings right here. And we're going to be looking to override our material. So look for material, set all materials. Sorry, no, I got that wrong. We don't actually want to do it here. So we can actually close this. What we want to do is we want to modify our place build. So right here. And we need to have it do, well, something else. So we can just move this to the side. We want to take our information here and we want to say, I believe it is called update size. And what our update size does is it just updates the materials based on the direction. And because we're not changing the direction, it'll just be updating it back to its original color or its original appearance, let's say. So for here, we want to get vector size, just plug into vector size, and we want to get location offset, which will also plug in right here. So now normally, if we go and here, so we still have a problem with these ones. Sorry, so what we want to do is we also want to actually modify our create here. And on this right here, we want to get a branch. Yeah, so we want to get a branch and we want to get our already placed like this, plug it in. And what we want to do is we want to do this same loop here once again. Actually, no, we'll just copy it directly from our place build because we want to do exactly the same thing as this. So copy that, place it here, and I believe it's on true. We want to do this. So we just plug this in here. Now, one last thing we need to do for this to work, we need to actually inform it how, or at least which one's already created. And to do that, we need to go and refresh our spawn actor in our first person character where we have our spawn build. Right click, do refresh nodes, and we want to uncheck this because this time we're actually placing it manually, meaning it should do that. So here it's working, and they've already changed color. Now if we add it here, it's going to be transparent as it should be because we've told it that it is. And once we place it, it should go back to its right color. So the reason this is happening is because at the end of all this, we're doing our update and then we're informing it to do its base function, which is set all to default. So it's just resetting to default. So we just want to place this here instead, and we'll return this right here. Like this. There we go. So that should fix our issue. If we go and place another line, and they have the right colors, correctly done. Okay, so now we can move on to the actual part of the video, the energy. So with that out of the way, we can now move on to the actual main part of this tutorial, and that will be working on the electricity and energy. So to do that, let's start by importing the asset we'll be needing or using for the poles. So in our assets folder, we'll put it in buildings. Go ahead and just simply drag that in. There we go. Select import all, and there we go. So before going into the actual details of the electricity, what we'll do first is we will set up the kind of movement of the pole, and the wire mainly. So to do that, we want to create 3 assets. So in our blueprints, the first one is going to be based on builds. So we're going to create child, and it's going to be a builds, and we'll call it electric pole. Then we can just duplicate this directly, and this one is going to be called cables. There we go, and that's for in between the 2 poles. And we want one last blueprint, and this is not an actor, it's going to be a scene component, and we'll call this SC electric node. And what this is going to be for, it's for where we attach our cables on the actual different buildings, on the electric poles, but also it will be handling all the energy, so the consumption and the generation of energy. So let's get into it. So we're going to start by doing the movement, and so we'll start with the electric pole for that. So just like any other one we've made before, we want to start with a static mesh, and the static mesh we'll be using is the electric pole. And that's all we have to do here. There's nothing else, simple as that. Because now if we just go and add an input, or what we can do instead is we can maybe modify what we already have. So if we go to our player here, and inside of our event graph, we'll change object 5 from a merger to our electric pole. So let's go and try this. And we do 5, we have our pole that appears, we can place it, no problem. So that's all we had to do there. Next is a bit more complicated because next we need to do the cable, and the cable works very similarly to what we did with the conveyor belts because it needs a start and end. It needs the actual electric pole if there is nothing, so it needs a bit more work. So let's go ahead and do that. Actually, one last thing first before we do that. We're going to add our actual component that we just made, the SC electric node, and we're going to place it where we want to attach our cable. So just put it around here. It doesn't have to be perfect, just kind of where you would like it to be. So we can then close this. We won't be needing it for a bit. Same for, actually we'll leave Satisfactory player just to change our cable here for object 4. So this is just which input we're using. So compile and save and close this, and we will open our cables. So there we go. Make sure you open full blueprints. Now, so the first thing we want to do is we're going to make a few variables. So the first variable we want is going to be start placed. So just like with the conveyor, we need to know when we've placed the first point and we want to attach the second. So with this, we're actually going to make a macro as well. So we're going to make a macro here, and this will be is start placed, and it's going to be start placed with a branch, connect it here. There we go. And we'll just move it a bit to have a bit of space. We can call the outputs true, or in my case, I renamed them to is placed and is not placed, just so it's clear which one we're talking about, because true and false may not give you the best idea. Next, we're going to need a few more variables. So the first one, well, actually, we're going to need three, kind of. The first one is going to be called start pole, and it's going to be of type A builds, and we're looking for our electric pole here. We can duplicate it twice, sorry. The second one is going to be end pole. So these are pretty much where we start and finish if we don't have any other poles. But then we also have overlapping pole, and this is just going to be used when we are updating our location. If ever we hit a specific pole, we can know which one it is. And the last thing we need is we want to know what we're connecting to. And so this is going to be our actual component that we made. So we want two of them. We want start, connect, and we'll just change the type to SC, and we want build. No, it's just, I think it was node, right? Or I've forgotten what I called it. So it is SC electric node, sorry. So select that and duplicate it and change start to end connect. And that will do it for all our variables. Now we just want to add our component, which is our cable component. So let's grab that here. Now, one thing to note about the cable component, which is by default in Unreal Engine, is it doesn't have any collisions. So what do I mean by that? If we look at an object here and we show our collisions here, we can see that it has a collision, and this can be generated by ourselves if we want by opening the actual static mesh. But if we take a look at the cable here, it actually doesn't have any at all. And I don't believe we can modify that because we have no access to it. It's not exposed to blueprints, the static mesh at least. And it is worth noting that it is currently set to physics actor, so it should be blocking collisions, but it doesn't have any collision to block. So because of that, we can't actually do a deconstruct on the line itself. So that's something we'll have to take into account by just deleting them when we delete the posts. So that'll be the only kind of issue with this. There are plugins that allow you to have different cables that do have collisions, but I just wanted to keep everything without any plugins for the tutorial. So just to let you know, in case you try and do this, it's just you can't because there are no collisions. So let's leave that. So back in here, we have a few functions we want to override. So the first one we want to override is the update location. So get that right here. And we've gone through this before, but obviously we're going to have to do it again. So we will start by getting our is placed. And that's the first thing we want to check. If it is placed. If it is not placed is what we'll do first, because this is what is going to happen first, because it's what we click. We will start with the sequence. And right here, we're going to get our hit information. So just search for get hit information. We're going to break the node. And we want to get our hit actor, and we want to cast it to electric pole. Like this. There we go. And with this, now there are currently some functions I believe that we don't have yet, but we'll just manage it for now without. So what this is going to be for is later we're going to have a kind of widget appear once we overlap a pole, so that we know how many more we can attach, how many more cables can be attached to this pole. What we want to check here is we're going to reroute this because we have quite a few things we need to check, so bear with me here. First, we want to check if it is not equal to the end pole. And the reason we do this is just so we can tell which one is, if it's start or if it's end. So I'm just going to do it like this. There we go. Let's put it in a branch. And pretty much we're just checking whether we are calling the same function again, so to speak. So what we'll do on false, so cast failed, we're going to reroute, and we're going to reroute here to the same thing, but what we want to check is if overlap pole is valid. Now, the reason for this is very simple. If it is valid, we want to call the hide widget function that we don't have yet, but we're going to be adding in a second. Or once we get to our actual widget, we'll do that then. It's more kind of linked to the electricity later functions than the kind of movement. So for now, we just want to add if this is valid, or if it was valid, we want to make it invalid now. And so the same thing will be done here for the start connect as well. So like this. And the reason we call here end pole is because we want to make sure that we don't attach it to the end pole. Sorry, no, this is actually useless because this can't happen. Because we'll never actually be attaching the end pole because this is the start. So the end pole doesn't exist yet. So just put this here. Uncast failed. So we're obviously still going to need a few other things, but we'll get to that in a second. So uncast failed. On overlap not valid, we want to create one. Or we want to update it. But first we'll just do this here. We want to check if this is equal. If the overlapping one is valid, we want to check if it's equal to itself. And if it is, we don't want to do anything because that means we're overlapping the same actor again. So there's no point in recalling the functions every time we overlap because that would be a waste of resources. So here normally we would call our hide widget for the old one because we're going to be updating it on false. But since we're not going to be doing that here, we're just going to put a reroute for now, a reroute here, and just connect these two up. Now, once we arrive here, we need to set our overlapping pole to the new variable, to our new object that we just hit. Go. And we'll obviously here, from this, we can get our our SC power, or electric, sorry. So get our SC electric node, and we're actually going to be able to promote this to our start connect here, because that's what it's for. This is the whole point. It's just so that we know that we've connected to something. And that's why obviously when we no longer hit something, we remove it here. So now we can actually do the movements. This sets up the visibility of the widget later, and it tells us which pole we're connected to, if we are hitting one, obviously. Now we're going to copy our hit information again. And on the second one, we won't actually be looking, well, we're looking for the actor, but we don't care what we hit here because it doesn't matter. What we want to know is we want to get component by class, and we want to look for the actual component SC power node or electric node. It's different on my projects, that's why. So the electric node here, this function, if you don't know what it does, it actually checks through the components of the actor to see whether it can find this component specifically. And if it does, we can check if it's valid to see that. If it's not, we'll be doing something different than if it is, obviously. So first, we want to check whether the actor hit here, so a reroute is needed. Is it equal to start pole? Now, the reason we want this is because by default, start pole can actually be hit because we actually spawn it, right? We haven't done that yet, but once we spawn, it'll be like the conveyor belt. We will have a starting pole that already exists no matter what. And if it does, if we're hitting it, we don't want to do anything because we're going to be updating it manually ourselves if that is the case. So if that is the case, we want to get our actors to ignore, and we want to say add, just simply add, and plug this in here. So we'll just add a reroute down the line, just it's a bit more readable. There we go. So connect these up. Just move this down. And next what we want to do is with this, our actual class hit, sorry, not that one, we want this one. So now if this is valid, we know that we hit an electric node, and because it's a scene component, it actually has a location. So first we'll be setting it to our start connect, because all of this, by the way, is linked to the start, so we just use start for everything. Go, just line these up a bit, move it up. And with this, we can simply, get world location, and we can tell this actor, so set actor location to be world location, like this. And so we don't have to do anything else here. We just want to say, if we're hitting something, because this is the case where we hit another actor that already has something that isn't the start pole, we can tell it to set the start pole to hidden. So set actor hidden in-game. And we'll be deleting it later. We don't want to delete it now because it might still be useful if we unhover it. So now these two here will lead to the same result. So we're going to be calling, obviously here, our start pole exists all the time. So if this happens, we want to update location based on it instead. So it's very much like what we did with the conveyor and the conveyor poles. Or the conveyor supports, I think I call them here. So here we want to get our hit information again. And this is the one from simply our input, so the same one as this. And then we simply want to get our start pole, is we're going to want to get our SC electric node as well. We're going to get its world location. And we're going to do the same thing here. Actually, we'll just copy that directly. And this is how it should look. There you go. So here now, obviously, we can make it not hidden. So this should actually be ticked. Sorry, my bad. There we go. And we can compile. So this will actually do all the beginning. So once again, it goes through and checks if we can find a electrical node that it hit that isn't the parent or the actual pole that we spawned ourselves on begin play, which we haven't done yet. If not, if we didn't find it or we hit the same pole, then we want to do update location of the start pole simply, and we will be attaching our actor to that location. So, and there we make it visible, and here we hide it. So now we just want to do the same thing pretty much with the is start placed. So this is going to be pretty much the end. So we'll start with the sequence. It's going to be very similar again, because it uses mostly the same stuff. So one thing we can do is we'll just copy this for now. And it's pretty much identical. We just need to change the things from end to start. So one thing here we do need to do though, is we don't want to do any of this if we are hitting the same pole. So here we do want to put a branch, and we do want to specifically say if this is different from our start pole. There we go. It's like this. So then we can put this into true, plug it in here, and we can move it a bit down. Overlapping remains the same. We don't need to worry about that. We don't need two, but we want to make sure that we change our start connect here to end connect instead. And obviously the same here, change this to end connect as well. So now we can move into actually moving our item. So for some reason this isn't connected. There we go. I'm sure it's connected. So we'll move this a bit further because we need a bit more space. So the first thing we want to do is a sequence here. This time we do want to start with a sequence because it's just easier to read if we do. And we're going to start by copying this again, because it's going to be identical. So start with this, and we will check if this is valid. Once again, plug it in here. And here we want to check, obviously, again, if it's, but this time with the end pole. So same trick as before, but this time end pole. Light it up. Now branch, false. And so once again, on false, we'll be doing the same thing here. We'll say update location, and we'll use our hit information again. Sticking these two up. There we go. Let's add a reroute so that it's a bit straighter and more readable. So if this happens here, we want to set our actor visible again. So actor hidden in game false. And this time we want to make a different thing here. We want to get our electric pole, electric node, sorry. And we want to get our world location again. So here, get world location, like this. And we want to inverse the transform. So we want to inverse transform location here. And the transform we want is get actor transform. And the reason for that is because our cable uses an end location here, but it's based locally. So we can't use world locations, so we need to convert them back to this. And we're going to promote this to a variable, which we'll be calling target location. Or you can call it end location, but target location will do. So set this here. Now, on the other hand, if it's true, we want to do very similar to what we did before. We're going to get this and promote it to end connect. So set, reroute a bit, and we'll do this pretty much the exact same thing as here. Actually, we'll just copy the whole thing, and we just want to connect our world end location to this instead. So plug it here. We can just line these up. There we go. And obviously we want to set this to hidden, because we don't want to see the end pole because we've attached it to something else. So let's compile and save. This is almost done. We just need to now tell it to update the location of the actual component itself. So we want to get cable components, or we'll just actually get cable here. I don't know why I'm searching for it. We will say set end location, to our target location, and make sure, by the way, you do a local variable. I forgot to mention that, but it should be local. And we want to also set cable length. And this is obviously up to you. It doesn't matter. It's just kind of visual. But for me, what I found worked well is we want to take our target location and we want to get the length of the vector. And we can do this because it's local. So it's always going to be relative to 0 because start location is always 0. So, and we want to multiply this by 0.7. So I'm not sure how the length actually works, but 0.7 seemed to be what worked for me. So now we just get to finish our place build and our few last little functions, and then we can actually test to see what it looks like. So we want to override now our place build. This. And just like with our, what's it called? Our conveyor, it's going to be a bit more complicated than just this. So we start off by getting our is placed, like this. And we'll start by it is not. So obviously, if it is not placed, then now it is. So we change this to true. And we want to get our cable here. And actually, I believe by default, I put it to hidden. So the cable, actually, we want to put it hidden in game to start. So set rendering hidden in game. We want to set hidden in game. And we want to set it to unchecked so that now it's actually visible. So let me just remove that. There we go. So now we want a sequence. And with our sequence, we're actually going to be able to manage what we do with the pole. So we want to get our start pole here. And we want to say actor hidden in game. No, not set. We want to get actor hidden in game and put a branch. Now, there we go. If actor is hidden in game, we don't want to do anything. We just want to leave it hidden. It's no problem. If it isn't though, so meaning we're using it, we want to place the build. So this is just calling from the actual actor itself, its own function for place build. On the other hand, right here, we want to actually place the new one. So we want to spawn actor from class, and this is going to spawn the end pole. So that's where it's going to be. So we want to get our builds, and we're looking for electric pole. We're going to promote this to a variable, our end pole that we already made. And for the transform, we'll just get actor transform. There's nothing else we need. It's just going to be relative to self because self is already just based on the old location that we placed it. So make sure you unchecked already placed, because otherwise it won't actually work correctly. And we can then tell our actors to ignore, so get actors to ignore right here. We want to add the end pole so that we don't consider it for collisions for testing the build. There we go. Then we can also reset our overlapping pole because we want to make sure that it's just for this thing. So just for the second part now. Make sure you return here false, because returning true means that it's 100% been placed and we don't have the update location called anymore, but we need it to be called because we've only done the first part. So for the second is placed, this is the finishing touches. So another sequence. And we're going to need a few more sequences than that. The first thing we want to do is we'll do the same thing as we did here. So copy that, and this is our hidden. And this time we will use the start pole as well, but this time instead, if the start pole is still hidden, we're going to destroy the actor. It means we don't want to actually have it visible anymore. We don't want it to exist because the whole thing has been placed. Now, if that's not the case, we want to have a reroute here, and we're going to do the same thing, but with the end pole, because the end pole can obviously be invisible as well. So copy this, place it here, and just right click on start pole and swap it with end pole. And obviously here we want to do the same trick, so we'll copy this. Could have copied that from the beginning, sorry. And just replace it with end pole. And if it is false, meaning that it is not hidden in game that we're using it, we want to do our place build again, just to make sure that it is saved correctly, like this. So now we need to handle the actual, well, cable itself. So here we want to go and say a sequence, and we want 3 sequences, or 3 parts. So the first one we want is we're going to get start pole, And what we want is we want to check if it's valid. So we want to check whether this has happened. And if it has happened, or sorry, no, if it hasn't, what we want is we want to get our SC electric node, and we want to promote this to our start connect, because this will be our new start connect now. So plug it in right here, and we will do the exact same thing, but for our end node as well. Just move this a bit. So right click on start connect, change it to end, and right click on start pole and can change it to end. Now here, what we do need to do instead, we need to do something here, but we don't have the function yet. So for now, we will put a return node and put true. There we go. So normally here, what we would do is we're going to tell our different poles and our different electric nodes to be connected between themselves so that they know which one they need to refer to for power later. So there's a few little things we need to do, and then we can start seeing if this works. So we want to get our create build now, and we can get rid of the parent, we don't need it. And we're going to start, actually we can copy from our place build, copy this. This is just the spawn, place it here, and all we want to change is just the end. We want to call it start instead. And so we then want to do, once again, I don't believe, actually, I just noticed something. In our date location in the start, we did this. We can just copy this actually, because we don't need this one specifically. We just want to put it in our create, right here. And we want to use our start pole right here. There we go. So line these up. And sorry, actually we do need the create build, sorry. So if you need the create build, you can right click here and say add call to parent function, and it will spawn this one in. Plug it right here. One more override, or actually two. We want to cancel build, and for cancel build we want a sequence, and make sure you have 3 pins, and the last one should be cancel build, otherwise it gets deleted before you can do the rest. We want to check for our start pole and our end pole. We're going to convert to validated, and we simply want to destroy them. So destroy actor. There we go. And the same thing here, destroy actor. There we go. Yeah, destroy actor. Plug these in. And the last one we need is we want to modify destroy build. So once again, sequence, we want to call this at the bottom. So sorry, we just need one here. Sorry, here we go. And so we want another sequence. And for the sequence, we want to get our start connect this time and get our end connect. And we'll do a convert to validated as well. We want to check, well, here we don't have them yet, but what we're going to do here is if ever we destroy this build, we want to say that we have disconnected the lines. And now they don't have this function yet, but later they will. So we're just going to leave them here for now. So let's plug this in. And we can now, I believe, close this, and we should be able to place all these items. So now I believe it was on 5, or was it on 4? I think it was on 4. So if we do 4, we have our line that appears, and we can place it, and there we go. Now I think it could be a bit thinner, but let's actually see first if we can actually connect a second one. So first, if we press 5, we just add a normal pole with nothing else. If we press 4, we can actually select our pole here and plug it into another one. There we go. And so now, as you can see, even if I look down, it doesn't connect there. It has connected to the other one. So now what we need to do is we need to inform them what that means to be connected. So I believe what we want to open first, because it's kind of a bit of both, we need to go back and forth a bit here. Okay, so I think the first thing we will do is I'm going to go into ElectricPole, and I'm going to make a few adjustments that we need to do. So the first thing I want to do is we're going to make our different functions in here that we could need. So we're not actually going to use them yet. We're just going to make them so that they're useful, or at least so that we can attach them in our more complicated thing, which is the electric nodes here, so that we can actually call these different functions. So the first thing we want to do is we want to make a function here called display widget. We want another one which will be called hide widget, and another one which we'll be calling update connected widgets. I think that's it. Yeah. So those are the three functions we're going to need. They don't need to have any inputs, and that's all we should need in here. At least for now. We will be needing some stuff later, but for now this is fine. So we can close all of these, and we're just gonna put them in where they need to be. So I'm just gonna get my references to be sure that we have them in the right location. So first, back in our build cables here, we're looking for our update location, and we'll be adding them here where we were looking earlier. So once we have our new overlapping, we want to call display widget here. So display widget. Plug this in here. There we go. Now, on the other hand here, we want to do the same thing. We want to get overlapping, and we want to say hide widget. Because obviously we're no longer going to have the same actor overlapping, so we want to change it so that it is visual, that we're no longer overlapping the same thing. So the same thing will obviously happen here. Here we're going to say hide widget, and make sure you place it before the renaming, otherwise, or the resetting, otherwise it won't work. So we'll need to do the same thing here. So we want to get our overlapping pole, say hide widget, like this. I can't seem to connect it, there we go. And in between here, it doesn't have to be in between, but just easier. For overlapping pole, show display, widget, plug it in. Go, and right here, same thing, we want to hide the widget. There we go. So compile, and that I believe should do it for these ones. So that will do it for the hide and display. Next, we want to look at the update connect. Okay, so the update connect is actually only used locally. And so I believe we can start setting this up now. So we don't need any of this, I don't think. We want to keep that just in case. We want to now add something right here. We want to add a widget. And I'm not going to make this widget yet. It's just so we can do the whole functionality, or most of it at least. And then we'll move on later to adding the widget. Hopefully this doesn't cause an error if we just have a widget sitting around. No, it doesn't. Okay, so that's good, because I was worried that might be the case. If we select it, okay. So first things first, we can put the widget a bit higher. 385 is good. And we'll just set its size now. So 1920 by 180 on the draw size. And we want to put it 0.05 on the Y and on the Z. So this is just that it scales down to be something appropriate for what we need. The first thing we want to do is we want our event tick here. And the event tick is going to be used if the widget right here is not hidden in game. So right here. And it should by default be hidden in game if I'm not wrong. Yeah. So sorry. So we just want to do one last thing for the widget, which is set it to hidden in game. There we go. And so if it is not hidden in game, we want to use the tick. So like this, just move this. Go. If it is not hidden, we want to get our widget and we want to set world rotation. So make sure you put this on false. And we want to split our new rotation because we specifically want to change the Z. So we want to get player camera manager. We want to get actor location. And we'll be comparing this with the find look rotation. And the target being obviously the player camera, and the widget itself is going to be the location we want with the get world location. So start, and we can split this, and we just want to connect the Z. So what this will do is it will make it so that the widget in world space is always looking at the player, or the player can always see the widget like a billboard, for instance. So what we need last to be able to actually finish our updated, to be able to use this, we need to go into electric nodes, and we want to make 2 event dispatchers. The first one is going to be called for a cable connected. And the second one is going to be the opposite. It's going to be cable disconnected. There we go. So compile. And in here, we now get to select our electric nodes here and say connected and disconnected. Now on connected, we want to update our, I believe, well, it's just update connected widgets. So There we go, just line these up, and we'll do the same thing on the bottom, but on the disconnected, on the line attached, we want to have a delay here, just so that we can see where we attached it for a split second before hiding the widget itself. So you'll see how this works once we get to the actual widget itself. And I think that will do it for the functions. Yeah, we don't need anything else for now. We will move on to the more important stuff. I'm just going to check if we can... Yeah, so we can actually just quickly do the display widget here, because it's very simply just taking our widget and saying set hidden in game to false. And obviously for the hide, we're going to set it to true because new hidden. For now, we can't do the last one because the last one requires our widget to be done, and we haven't done that, so there's no point in doing that right now. So next we're going to move to the electric nodes, where most of the logic is going to be. So first let's start with the variables. So the first variable we want is a power consumed variable. This is going to be a float, and what it does is it's simply going to track on the local building, so specifically the building this is attached to, how much power is consumed. And we'll do the same thing for how much power is generated, like this. And both of these need to obviously be exposed, because if we want to change them on each building, we can do that. So next we want something called max attachments. Yeah, so max attachments, what it does, it's an integer. It will tell us how many we can attach to the actual building or to the actual electric pole in our case. We put 1 by default, because by default you always want to be able to attach 1 if this node exists. But for instance, in the electric pole, we will tell it to be something like 4. That's how we can put 4 on them. Next, what we want is we're going to want something called attached cables. And this is going to be of type cable and a builds cable right here. And the type we want to use here is we want to use a set. So the reason we use a set here instead of an array is because a set allows us to automatically have a system that only has unique values. And because a cable can only be attached once anyway, it's much easier to just simply use a set. We don't want to bother with adding unique, etc., because we can only have one in a set anyway. We also want another one, but this is going to be for connected nodes. So very similar to what the attached cable does, but this time with the SC electric. There we go. And we're looking for the bottom one, which is nodes. So this is ours. And next what we want is much simpler. We just want a consumed array. And so this is going to be very similar to our float here. And this time we do need an array because we can have multiple times the same number. And this one is going to be obviously for generated. So what these are going to be for is when we later make the kind of graph that displays how the energy has been performing over the past like 10 seconds, this is where we're going to store that information. So to help store that information, we're then going to need a timer, which we're going to be calling array timer. It's going to be a timer handle. And we don't need it to be a array, so just right click to turn it into a single variable. We then want something called max array size, and this is so that if you want to modify the amount of information that can be stored in here, you can. So by default, we're going to put it to 11, because that means 11 points along the graph to track the information. So compile and save, and this is all the functions we need. All the variables we need. Now we're going to do the functions. So we'll start with getting our connect line, and then we want our disconnect line. Now, both of these need the same inputs, and that is they need to know what cable they're attaching. So we'll look for cable, a builds, and this is attached or connected, sorry. And we will actually just remove that and duplicate it, and we'll call disconnect line again, and we'll call this disconnected instead. There we go. So compile, and let's go through this very, very quickly. So in connect line, what we want to do is we want to start with a sequence. On our start of the sequence, we want to get our attached cable, and we want to add and then we want to add the connected that we input here. So plug this in here. Now, in addition, what we can do is, or what we're gonna do, is we also want to take this opportunity to do our connected nodes. Now, for the connected nodes, what we want is we want to get connected. We want to get start connect here from our actual cable, and we're going to check if this is different to self. And the reason we do this is just to check that which one we need to use. And so what we can do then is actually, we don't need to do it like that. We can do it as a select instead. So we want to get a select node here, and we will leave it empty for now. And for our connected nodes, we're going to add and connect this here. And the add is obviously going to be our return value here. And to select which one we want, we simply copy this, and we'll do the same thing, but with our end connect here, like this. So line these two up, not like that, line these two up like this. If start connect is different, then we can use start connect. If not, we use false. We use the end connect. Just move these along. So there we go. So what this will do is it will just add the linked connect on the other side of the cable to the nodes of this electric node, so that it knows which one is which. Now, the last thing we need to do is at the end of our sequence, we're going to need to call our cable connected, but we also want to call another function. So we're going to make that very quickly, and it's called start timer, or timer. There we go. So we can compile here. And so right in our connect, we want to call our start timer. It doesn't need to have anything else. It can just be this, and we connect it here. Now on disconnect, it's going to be very similar. For disconnect, we will put a sequence again. And this time we will call our disconnected on false. And we'll also be calling another function, which is called get energy information. There we go. This. And so on disconnect, we want to call this one right here instead. Unlike with our previous one where we were connecting, here we're disconnecting. So we want to get our attached cable, and we want to say remove item. And we get our disconnected, line these two up, and connect it here. Now we're going to do the same trick as we did before. So we're actually just going to copy it. So we'll do the same thing here, and just re-go to connected. Now it'll have a little error because we're not using connected but disconnected. So just line this up, remove these, and get our disconnected instead. And there we go. So now it's all lined up properly. This. And so now instead we just want to say remove instead of add. And we are done. So now this will handle removing items as well. Or disconnecting, more like. Now the next thing we need to know is we need to know, can we connect the line in the first place? So we simply want to make a can connect function. Or more like can connect cable, sorry. Cable. It's going to have a return, which is going to be a boolean, so return value we'll call it. And to calculate it, it's very simple. We get our attached cables, we get the length of the attached cables, and we check whether this is still inferior to our max attachment. So plug this like this, and there we go. So we can also, we want this to be a pure, as well, just to make it easier. Next, what we want to do is we want to tell our connected nodes what to do, or our nodes specifically, what to do if they are destroyed. And if they're destroyed, we want to destroy our linked cables. So we want to be able to inform which things are attached. So here we get our attached cables. And we can't do a for each loop with this, but we can go to array and then use that as a for each loop. So like this, plug it in, and now we have our for each loop. So for the for each loop, we simply say, actually, no, sorry, not a for each loop. We want a reverse for each loop. And the reason for that is because it's an array. So if you delete the first value, we'll move on to the second, but the second has now become the first value because we deleted it. So here we want to say destroy build like this. And so now we'll do it from the back or the end, sorry. So that's a better way to do it when we're deleting stuff from an array. So another function that we won't be using just yet, but we'll make anyway, is the question of do we have enough energy? This is going to be used for crafting. So once again, it's a boolean, so a return value. It's going to be pure. And what we want to check is not whether these values are important, but this one. We want to know specifically how our consumed array is doing. And so what we want from our consumed and generated is we want to check our last index. So first we want to get a copy, and we want to get last index. So just type last index, plug this in here, and we want to check whether consumed is inferior to the same thing, but for generated. So like this. And if it is, that means we have enough power to make or craft or whatever we want to do. If not, then it will turn false, and we cannot. The last functions we need right now are the actual get energy that we made here. So the first thing we need to use get energy is we actually want another function which is going to be called get all connected nodes. Now this may sound strange because we have our connected nodes here, but the thing is we don't want to just know what ones are connected directly, we need to know which ones are connected down the chain. So to do that, this is what that function is for. Now this function needs to take an input of type nodes. So we're looking specifically for our electric node. So all the way at the bottom, there we go. And we want to put a set because we're using our same logic as here. And so we want to call this, well, nodes to ignore. There we go. And we want to have the same thing for the return, and this is going to be all nodes. Okay, so forget all connected. Let's go through this one first. The whole point of this is just to know every single node that we have. So the first thing we need is we need a local variable. So we're going to promote this to all nodes. And make sure you put the L before, otherwise it will consider it the same as that, and that's not what we want. Now we can't just do that. We do need the set, but what we want to do is we want to do a union between these two. So we want to get our nodes to ignore. So we're looking at that one, and we want to union the two of these like this. So there we go. Plug this in, and make sure you connect it here, because by default this isn't a set. It needs to actually store the output somewhere. The next thing we need to do is with our all nodes here, or no, sorry, our connected nodes. So we want specifically this one. We want to do a for each loop. But because of this won't work, we also need to once again do a to array to be able to plug this in. So let's go like this. There we go. So what we need to check here, and make sure this is kind of important, otherwise you're going to end up with infinite loops if we don't do this correctly. We want to check whether our ignore here, so the ones we're trying to ignore, if we contain the element we're trying to look for here. Because if we do, that means we've already performed this action within it. Because how this works, the only way to get this kind of system to work is to do it recursively. So we want to check whether it does not contain this boolean, or does not contain this element. And if it doesn't, then we can actually perform the action that allows it to do it again, to call it for this action itself. So the first thing we need to do is we actually need to inform it that it can be added to all nodes, because all nodes needs to store the total at the end. So we're going to add this element to it. So let's just reroute this because we're going to need it again in a bit. And right after this, we want to call from this specifically point here, make sure you connect this, get all connected nodes. So it's going to call itself pretty much as long as it can. And so what we want to ignore this time is we want to ignore all nodes. We want to ignore everything that's already been added to it. And so because of how this works, we're adding all nodes and ignore together right at the beginning. So the output can be straight away set to the all nodes because it's being updated and added within this function itself. And on the return, so right here, we simply want to return our all nodes that we've been updating throughout all the different elements. Now, how this works is it really just goes through, takes everything together, puts them into the all nodes. It checks whether out of the connected, any of the ones that were previously in the all nodes need to be ignored. So anything that has already been added will not be added again. And if it hasn't been added, it gets added to the item, to the array or the set itself. and then it checks within itself, are there any other ones that it is connected to that need to be added to that same array? And then once it's done, the only place that calls it is within our, I believe we can open it up again, our get energy. This is the only place that we're going to call it from. So it will only get called once from one location, and then the rest will happen with it, but it will manage to get everything thanks to the recursion that we set up. So here we want to call our get all nodes, and to start, because it's a set, we actually need to make a set. And to start off, we want to put self as a part of it. And make sure you put self, otherwise you'll get errors of an empty list or an empty set, and that'll be causing some issues with what we're going to do right now. So now we want to go through this list of all of our items, and we want to say to array, because we need to know what array it is, because we need to have a for each loop. And now we're going to be able to get our power consumed, we're going to be able to get our power generated, and we're going to be able to add them to themselves. So here we want to make a local variable. We'll call L total consumption. Oh, consumption, not with a J at the end. There we go. And we'll do a duplicate, and we'll do a duplicate for generated. So obviously this is going to be not set directly, but plus for consumption, like this, and line these up. And we'll do the same thing here for the generation. So right click, turn this to generated, and we will drag generated right here as well. So plug these two in. And now we have our generation consumption total. And so now what we want is with that, now that we've gone through and added everything, we can do another for each loop on our completed, where we get all this information from here and say to update those specific values. So just to make things easier, we're going to make a function for this, which is going to be called update array, which simply takes in the float input for the consumed, and the same thing for the generated. Now what this array needs to do, or what this needs to do, is we need to get our generated array, or you can also use the consumed, it doesn't really matter. We want to check the length and see if it is already too large. So we're going to check if it's superior or equal to our max array size, which is 11. And if it is, we're going to delete the value 0. So we're going to delete the first index. And the reason for that is that we remove the first value because it slides as it goes along, because we're checking the latest one as the value that is important. So we get generated, we say remove index 0, and we can just immediately duplicate this and plug it into here and just change generated to consumed. And if it's false, meaning that's not the case, then we simply reroute and reroute here just to connect them all. We simply go and say add for both of them. So add like this. So we'll add it to the end, and the same thing here. And like this. And what we want to do is we want to add our consumed here. So the input here, we want to get generated like this. And that'll do it for our modifying or updating array. And so back within our get energy information, here we want to call update array, and we want to plug in our total consumption, our total generated, and that'll do it. No, I don't think, no, that doesn't do it yet. We're not done yet. Because now we also need to do one last thing, and that is we need to make sure that with our timer that we've made here, we haven't set it up yet, but with our timer, we don't want our timer to be called on every single node, because that would eventually, if you have hundreds upon hundreds, then every second it's updating. It's not a big complicated thing to do, but every second on every single pole would be tremendous load on performances. So we don't want that. So what we simply want to do is we will go through the list of each and every one there is and tell it to only perform to deactivate the timer if you're connected to the one that we just plugged in. So because this gets called on only when we attach it, so I believe it's called, when this is called, it's going to be called in the timer, and it's going to be also called when we disconnect. And what this will do is that now we're going to tell it to only perform or more like to cancel the timer if it is not equal to self. And so self being the one that just called this. So that means it will only be getting called once out of all the nodes that are interconnected. It'll only be called on one of them, and it'll be updating all of them. So to do that, we want to reroute here, and we're going to get owner, because we actually need to have something here for if we are building. So this is cast to a buildings, like this, and this is just to tell it, hey, if you have enough energy, we are going to check, or like, if we call this, it's only getting called every second. So we check every second whether we can actually update it, whether the energy is enough. So right here, we don't have the function yet because we're going to do it in a second. Actually, to be fair, maybe we can just do it now. So we have crafting here. We're just going to call can craft for a second. Yeah, so right here, in our modify output map, we have pretty much something in essence that is a function that checks whether we can craft or not. So we're going to collapse this to a function which we will call attempt crafting. And I believe we can also call this, we can also copy this and put it in, I believe, modify input as well. This is modify output. Do we not have modify input in here? We should have modify input. Yeah, so modify input, same thing here. Just place this right there instead. And what this allows us to do is it will check whether it can craft here based on the actual resources available. So we'll call this attempt. We have attempt crafting, plug it in here. If not, we just reroute and continue as if nothing happened. It doesn't matter. And sorry, make sure you connect this here. Now we want to keep going here. And as I mentioned, we're going to check whether this is different from our self. And so if it is different from self, so we'll put this as a branch. If it is different from self, we're going to stop the timer if it is active. So we're going to get array timer, just put another reroute here, and we're going to check if it is valid. And if it is valid, that means we want to stop it because it shouldn't be happening because there is only one that needs to be called. So we will call clear and invalidate timer by handle, like this right here. There you go. So this will do it for this function. So now we can put a return node because we are done. And I think that is the last thing we need to do in our electric nodes. So there's actually one last thing we can do in our A buildings here, because even if this happens, nothing is actually taking into account the electricity. So we need to modify our can craft to take that into account. Now, to take that into account, we actually need to add a new piece to it. And that piece is, we need to add our SC electric node, because even though right here we won't be using it, we need to know that it exists to be able to perform the can craft on this specific location. So for this, it's pretty simple. We already made a function for it right at the beginning. So right here, we are in can craft, right? Yeah, right after our recipe check, we had another branch, and we can just control drag here so we don't have to drag to the side. We're going to get our electric nodes. We're going to check if we have enough energy. And if we do, we can craft. If not, well, we cannot, so we just put it to false. So now we can close A buildings. We won't be needing it anymore. And we can go and set up the last bit in our cables here. So we won't do anything in update. We want to modify here in our connect. So I can close that here. So in our destroy build, we can now call our disconnect line, and the line being self. So just place this here. And we can do the same thing, obviously, on both of these because it's the same thing. Just make sure you connect the target. So that will do it for destroy build. And now in place build, we need to do something similar. So in place build, there we go. In place build here now, we can actually call our function. So what we want is we want to get end connect, and we're going to say connect line. And we also want to do the same thing for start as well. So bring it self here. We're going to also duplicate this, and we can actually connect two here because it's the same function. We want to connect start and plug this into the return. So let's move this to the side here. Line these up. Let's make it a bit tidier. And there we go. And that should do it for our functions here, I believe. So one last thing we can do just to make something very quick. Now, I'm not going to actually make, I'm now going to make an actor for the energy. And so for that, we're going to simply use our A builds here. We're going to create a child, and I'm just going to call this energy generator. Now, energy generator doesn't have the SC that we made earlier, so we're just going to add our electric node, and we're going to make it generate something like 100 in energy. It only has one attach point, and we're just going to add a cube to it, and we'll just make sure you detach this if you actually want to move it. I just realized, because otherwise it will not work. So we're going to place this somewhere along here. Doesn't have to be perfect, it doesn't matter. And so by default, this we're just going to place into the world. And normally, if everything is working correctly, we should be able to just press our 5, which is just a node. If we press 4, we can connect it here and plug it to our actual box here. And so it placed correctly, and now we should be having energy here. And if we add another one, so I believe it's with 4, we can just put an intermediate one, if I'm correct, if it lets me. There we go. For some reason it's not letting me connect it there, so we'll have to have a look at that. If we connect it here, and the reason it's at the bottom is because it's at 0, 0. Okay, so it's not actually letting us connect it. Oh, I think I know why. So the reason is probably because, yeah, our electric pole by default is still 1. So if we set this to 4. Oh, sorry, I know why. So in the function here for our cables, there's actually one last function we need to update, and it's the isBuildable, because we haven't told it how to handle things like can you connect. So that's what we need to add here. And so we can get rid of these, we don't need them. Well, we need the return, and won't let us get rid of that. Get our start placed, and on start placed is not placed, so we want to get our connect here. So start connect. We want to split, attach it to is not placed, and if it is valid, so if it isn't, sorry, we want a return node, and the return node is simply going to take our start pole, and it's going to get is the start pole buildable. Because we don't really care if the cable is blocked by anything, that shouldn't be an issue. For if it's valid though, we want to get can connect cable, and that's going to be our return node. Let's plug this into is valid. We can copy this for the is placed because it's the same thing. We can actually get rid of that now. Just need to replace this with end and replace this with end as well. So let's pick up iron here. If we connect iron, there we go. So now if we just drop some iron in, nothing happens because it doesn't have any energy, and it still remains there. If we go and grab our generator here, so on 4, we connect our generator, and we add another link between this and this, it should start crafting. The reason it's not working is simply because we haven't told it to do anything. Because currently the logic in here is working, but the problem is we haven't told it when to do it. So we actually need to set that up, and that's me being stupid. We completely forgot the timer. So here what we want to call is we want to say set timer by handle, or by event, we'll call it. Yeah, by event. Put 1 second here, and we want to make it looping, but we want an initial delay of 1 so that it immediately happens. This is going to be set to the array here directly, and we're going to be using the function that we made earlier, which is the get energy information. So plug this in here, and this should now do what we want. So if we go and connect these two, 4, so we have our line here, if we go and press F8 and select at this and look at our nodes, we can see that the number is actually changing. Now consumed we have 0, but generated we have 100, and it's slowly getting back, but once it hits 10 it will go here. Or yeah, so it has 11 elements and it's not consuming anything. But if we now go and connect our node here to our actual something that consumes, and we give it something to do, so with our iron ore here, currently it's not doing anything, but if we add this here, it'll start producing. And if we have a look now at our information here, it should be now consuming normally, I believe. So I think it is consuming. It's just that by default, this right here, our building, if we look at our electric nodes, it doesn't have any power or isn't consuming anything. So if we change that in our settings, so if we go to this, actually that's one thing we do need to change that I just remembered. In our actual buildings, we want to make a slight extra modification, and that is we want to manually change the energy consumption. So we want to put a new variable called energy consumption, and this is going to be a float. And the reason we want to do it this way is because we want to tell it to only say that it's consuming energy once it's crafting, because when it's not crafting, it shouldn't be consuming energy. So to do that, what we need to do is in our event graph, so right here, we're going to get this and move these a bit to the side. So we need a bit of space. We're going to get our electric nodes and we're going to say set consumed power. So like this, plug it in here, and we're going to put this here for resume. We're going to put this here for start, but for stop, we're going to put 0 because it means it's no longer consuming, so it shouldn't matter. So we plug this back into stop, we plug this back into start, and plug this back into play. So now if we go here, by default it won't do anything again because our smelter itself still is set to 0. So we want to go into our class defaults, look for energy consumption, and we'll put something like 40. So what we need to do is actually we need to call the start timer on begin play. Now I would love to show you how to do this. You just need to call start timer here, but every time I do that, it seems to crash this project for me. So I have no clue why. Normally I would just delete the electric nodes and remake it, but because it's a tutorial and it's only a very simple thing, just simply add the start timer here and save it. So with that, you won't have the issue anymore of it not have, well, it's not an issue, but it won't have 0 to begin with. But now if we go, let's say, and connect with 4 here, our node there, and so currently right now this will start producing energy, or at least having the information that it has energy. So as we can see, we have generated 100 here. And once we connect it now to our second one, so our thing that consumes energy, if we go here, it's not consuming anything currently normally. If we double check, we go into our electric nodes, it is generating, but it is not consuming anything. Now remember that this generated is just everything. It's not specifically this item here. But if we give it something to craft, it'll actually start consuming energy. So if we look here now, and we go into our electric nodes, it is starting to consume 40 every time as it produces. So with that, we can now move on to actually showing this information, because currently it's not very visual, it's difficult to tell, but let's make it so that you can actually see this. So one other thing you can do is move obviously your, what's it called, your electric node if you want to. You can also delete it on other item or things like the container, because you don't actually want to be able to attach energy to a container. So what we'll do now is the actual widget. So the only thing we need now is the actual, I believe, electric nodes we'll need, and we'll be needing the electric pole, but nothing else. So for the electric pole, we want 2 things, or for the widgets, we want 2 widgets. One, which is going to be the main widget, which we're going to be calling UMG power or electric pole, we'll call it simply. And the other one is going to be another widget, which we're going to be calling UMG power graph. Now we're doing this separately because of how the system we're using works. So for the graph, all we want is a canvas panel and an image. And the image is going to be whatever color you want, but I think just having it be white is the best thing you can have. It's not going to take up the full screen. It's only going to be a part of it, but we just want it to cover everything so that we can resize it if we want. In the graph is where most of everything is going to happen. And so for that, we need to override a few functions. Not override a few, just one. We want to override onPaint, it's called. And so what this does is it's going to allow us to actually draw lines. That's what it's for. So to do that, we simply want to call two functions, which are simply going to be called draw lines. And we need two of them. One, which is going to be used for the consumed, and one that's going to be used for the generated. So let's have a look here. We need to plug in the context, right, like this for both of them. But for the information, we actually need a reference to our power generation system. So for that, we need as SC, and this is electric node. And so with this, we get our actual reference, so electric node, and we want to make sure we don't need this to be exposed on spawn, because we can't actually do that because it's going to be placed inside of another widget. So we want to check when this is valid only. We can actually call these functions because onPaint is called all the time. It's like an event tick of sorts. So just plug this in. And for the tint, we can go with orange for generated. We'll have this one be generated, and we will have blue for the consumed. Now, next we need a function that will give us these points. So we're going to add a reroute, and then we're going to get our consumed array here. And we're going to add another reroute, and we're going to select both of these, and we're going to collapse onto a function, just so it's easy to make. This is going to be called getLineInfo. It's going to be pure, and we want to actually get it again. So one thing to note is you won't actually be able to just simply do this like this, because it's going to call an error, I believe. Yeah, so it cannot be called on self, so I'm not exactly sure why this is or what this means, but to solve it, we simply want to call this as a constant, and that'll make the self appear here, and if we compile it now, actually works. So we'll do this here for, I believe we said consumed will be blue. Let's just move this down. And we'll be using the actual generated for the orange. So there we go, plug this in here and line this up, or give it a bit of space, more like. This is not actually going to be enough space, but that's fine. So there we go. So with this, we now have our lines that get drawn. We just need to tell which lines to draw and how to draw them. So inside of getLineInfo, we're going to go through the list, pretty much. So we want two variables, or local variables. We want this, which is lReturn, and we want another simple integer, which is going to be the index that we're going to be using. So like this, index, and here we go. So what we want is we want to get our electric node, obviously. We want to get max array size, and we're going to do a for loop with it. So call for loop, and we'll call -1 because that's how it works, because we start at 0 and we're getting the actual length here. So line this up. Now, obviously, the index is going to be here because that's what it's for. That's the whole point of an index. It's going to be used for the index. We can put the return on the complete. And now we get to just do a bit of math just to simply call the return here and call the add node at the end. So this is all that this actually does. It's not very complicated. We just want to then get the input pin. And we want to get a copy of the index, line this up, and we're going to check whether this is a valid index, because sometimes we may be using this and we don't have actually our 11 inputs. So if we don't, we simply select the float to be done 0, but if it is valid, we use the value that we have. Now we also want to multiply this by -1, and this is just because of how the draw lines works. It just does it negatively, and we want it to go upwards, so we just invert the numbers. And we also want to add 200, and this is the 200 that we're going to use is based on the size that I want the image to be. So if you want it to be 300 in height, then you put 300. That's fine. So we want to split this. This goes into the Y, and then we want to get our index again, and we're going to multiply this into a float. So we want to convert the pins here to floats, plug it in, line it up, and I put 30 because we're going to have pretty much 10 times that in length. So we're going to have 10 points, and that's going to be 300. So it's going to be a 300 by 200 thing. So we're done now with our UMG graph. Now we just want to do our UMG electric pole. Now here we want a canvas. Within the canvas we only want a few things. We want a button to be able to close it. So we're just going to put this here and call it close. And we'll just anchor it in the top. There we go. I think one will do there. There we go. So we'll just make it red so that we know that it's for closing. And then we want to simply add our power graph here. So we want to center this. We'll put 0.5 on both, and it will be 0, 0, and 300 by 200. Sorry, I put 5, not 0.5. There we go. So this is pretty much all we need to do here. We just need to inform it of what it is, because currently it doesn't know that. So on our event construct, we need to get that information. Here we can actually do the same thing. So I'm going to get our power graph here, and we're going to say set our node, and I'm going to promote this to a variable, which is going to be that. And this one we can make explode on spawn because we're spawning the actual widget instead of having it be already existing here. So on event construct, we do this. And once this is set, it will be able to perform what it needs to do there. And now we just need one last thing, which is an event dispatcher for closing, which will get called on button clicked. We will call close, and we'll also say remove from parent, like this. Line these up. And that should do it for everything in here. We don't need to do anything else. We just now want to actually call this on the electric pole. So to do that, we need to have our interaction. So go to class settings within our electric pole and add an actual interface. And we're looking for BPI interact. We select our two nodes here. For HUD, we're going to say interact, set interact text, and we will say interact with PowerPole, we'll call it. And on the other hand, for our actual, what's it called? For our PowerPole, we need to make some modifications. So, for our event interact, we need to do this. So what we want to do here is we want to make our widget appear. So we've done this time and time again. We want a custom event here called close widgets. Let's see if yes, it doesn't crash, so that's fine. So what we want is first we want to promote this just to make it easier. It's called interacting player. Plug this in here. And we're going to create a widget, which is going to be the widget we just made. So we're looking for our, I believe it was electric pole, we called it. Yep. And we want to attach our electric node to this. And now that we have this, we can promote it to a variable, which we'll call electric node, like this. And now we can check maybe as UMG electric node is probably better. So convert this like this, check that it's valid. If it is not, we can create it. And now we can just do our event. So bind event close, and we're going to bind it obviously to the function we made here, or the custom event, sorry, we made here. Plug it like this. And so if this happens, this becomes false. And then we can go pretty much to any other interaction we have ever made. So let's try and find one in our buildings, I believe, like right here. And we can just copy all of this, and just simply place it into here. And it's not going to recognize the interacting character, but we can just change that with our own in a second. Plug this in here as well. There we go. So just to replace this, we just need to right click with our interacting player. So right here, interacting player. And we can compile and save. And now if we have a power pole, so let's add one here, we can interact with it and we can actually see the line at the bottom there. Now I think we can make it a bit thicker because I think it's a bit too thin to be able to be seen there. So back in our power graph, right here, we want to go to on paint and we can actually make it slightly thicker. So I put something like 3, I think was good. So let's see what that gives. Now obviously right now it's not moving because we haven't given it any values. So let's plug it into here. And we can see it spikes up because now it has energy coming in. So that's 100 worth of energy. And we can see that we're not consuming anything. Now if we close it and we go and add another one here, we're going to actually see that now this will start coming up normally once it starts crafting, sorry. So we need to actually make it craft. And let's do just that. So now it's going to start crafting. If we look at our power pole, we see that it is crafting. And because it's under, it doesn't have a problem. So let's go and close this because we know that that's working. And I believe there's just one last thing we can do. So this is just once again aesthetic, and it's the PowerPole widget we made at the top here. So right here, this one that we can't yet see. It's the widget that allows us to know how many cables we can still attach. So let's go ahead and do just that. So once again, we're going to need 2 widgets for this. So one is going to be very simple. It's just going to be pretty much a gray square. Yeah, so one of them is going to be a UMG right here that we're going to call connected. And we're going to make another one, which is going to be called UMG pole connections, we'll call it. Or maybe pole cables will be better. Cables. There we go. So we'll start with the UMG connected, because that's much easier to do. It's very simple. We want a size box first, and we then just want a simple image within the size box. We don't want to make it too complicated. It's just simply going to change color based on what we do. So we'll make it grayish to start, not too dark. And the size, we will put it 200 by 200. So 200 by 200. Bar and save. And now we just need to make a few changes. So make sure image is variable. And in event graph, we're just going to make 2 functions, which are called set occupied, or maybe set connected is probably better. Connected, and set disconnected. There we go. So set connected simply changes the color to orange. So set color and opacity, we will set it to our orange. Sorry, no, this is set disconnected. Set connected is orange, and set disconnected will be to the gray that we currently have or something similar. It doesn't really matter too much. So just put it down here. There we go. So that does it. That's all we have to do here. We can close that. Now we just want to work on the other one, which is UMG pole cables. So for this one, we want a canvas this time. We want a text box that we're going to put here. And we also want an image, actually. So one other thing we also need to do very quickly is we want to make sure this widget is actually 1920 by 180. So just drag that down there and make the image fill. So we want to cover everything and make the text, or actually make the image pretty much black. And we want it to be slightly transparent. So something like 0.5, I believe was good. For the text, we want it to cover pretty much the entire screen, or a majority of the screen. So we want it to be fill to the top and 0 here. And we want it to be about 800 in size. And we're then going to have a horizontal box below, which is going to be the opposite, which is going to be at the bottom. And it's going to be fill on the bottom, obviously, sorry. And 0 and 0, and we want it to be 1 on the alignments on the Y so that it's actually above, and size wise we want it to be 280, and so that will just make it so that it takes up the whole screen. For the text, we want to make it a bit bigger because currently we don't see it at all. So 500 is good, and we want to center it. And I believe I use light, and pretty much for now it's just going to be 5 out of 6 just to test. That's what it's going to look like. And let's go and set it up so that we see. Let's just actually go look what it looks like. So in our electric pole, we want to select our widget, and we want to tell it which widget to use. So we're going to tell it to use the UMG, and we're looking for our electric pole. And now currently we don't see it because it is hidden. But if we go and interact with one, let's say, let's put one down here. Okay, so it is working. A bit strangely. So why is that? No, sorry, I put the wrong one. We're looking for the pole cables. That's my bad. Pole cables. There we go. So now if we do this, it'll look a bit better. So let's just place one there. And if we now go and look, we can see our actual information. Now, one thing to note is that currently it is not actually transparent. And so to do that, we need to actually change something very quickly. And so what we're looking for is within our widget here, so in our electric pole, we are looking for blend mode. And in blend mode, we currently have mask. We want to put it to transparent. So like this. And now if we put 4, we can actually see it. So currently it's not working correctly, or at least we want it to know how many it can have. So it's saying 5 out of 6, but we need to change that. So that's what we're going to be doing right now. So we want to have on event spawn, or at least in our event graph, we have nothing. We just want to make some functions. So we want something called max connections. That's the one variable we need. And that's because the max connections are never going to change. They're going to be set once, and that's it. So actually I need to make sure the horizontal box is variable, otherwise it won't work. And we're going to make a few functions. The first one is going to be make connections. And this one needs to take in the max connection inputs. So max connections. So that's going to be an integer. Then we want something called update numbers, which is also going to take an integer, but this one is going to be the connected items. There we go. And the last one is going to be update text. And update text is very simple. It's going to take our, we don't actually have our text box modifiable either. So make sure we make that is variable. And we're going to say set text. We're going to format our node here. So by getting our text, we say format. And we're going to say A out of B. And A is going to be an integer. So we're just going to plug this in here for a second so that we can get it here. And this is the current amount pretty much. There we go. And we want max connections here. So with this, we have our update text. Next, let's do the update numbers. So for update numbers, first we call update text because this is actually connected items. So it's the current. So it's exactly what we want. Actually, we'll probably start with make connections. That's probably easier. So what make connections does is it takes in max connections, sets it to the variable. Then with -1 from it, we're going to do a for loop. So make sure you select a for loop, not a for each. Plug this into last index, line it up. And on end, we're going to say update text. And this is going to be called on spawn pretty much. So that's why we can just leave this as 0. We're going to create a widget of type our connected, I believe, UMG connected. And we're going to get our horizontal box and say add child to horizontal box instead of add to viewport. And we want to make sure we update its appearance, so how it's laid out. So we want to set size here and right click, and I believe this is okay by default, but just to be sure. We want to then set vertical alignment, set this to center. And for the last one, we want to do the same thing on the horizontal. So set horizontal alignment to center. Just like that. And so now we can finish our update numbers because update numbers needed this to be done. It's a bit clearer. We want to get our horizontal box. We want to do a for each loop through all the children. So get all children like this. Plug it in. And with it, we then want to convert, or we want to check whether it's connection, whether we're using the right widget. So we cast to UMG connection, not container, cast to UMG connected. And what we want to do is set occupied. So we want to set connected, and we're not doing a check here, but we're doing a check after. And what we'll do is simply we're going to check whether the current index is superior or equal to the get connected items -1. And if it is, then we simply going to return, because if we return, we stop the loop and we finish the actual execution. So this will now update correctly everything within here. We just need to now go and call these functions within here. So let's go to our event graph. So the first thing we need is we need to now update our function here. We need to override our create build because we need to tell it to actually take into account this information. So we're going to get our widget. We're going to get widget again, which will get us the actual reference to a widget object. Then we can cast to UMG-pole cables. And with this, we can promote this to a variable, which we're going to be calling, well, as UMG-pole cables is fine. And we're going to say make connections, because this is called on spawn. We can get our electric node here, and we can get our max attachments and plug this in right here. Next is the actual updating the widget. So we have a function called update connected widget here, and we're going to call from our actual pole cables here, update numbers. And the numbers are going to be here, get connected, no, it's not connected, get attached cables here. And we want to get the length of that and simply plug it into the amount of connected items. So like this and like this. There we go. And one last function, and that is our, well, no, that's all. That should be everything. I'm just going to now check if we put it all in the right locations. This should be good. So now if we go and press 4, we can see actually that we're trying to connect it here. And we can have a max of 4. Now if we press 5, nothing connects. But if we go here and connect it, we have 1. Now if we do again here, it already has 1. And if we add a second, we have 2, and then it disappears. You can make it last a little longer if you want to, it's not a problem. And we can do this for as many as we want. Now it will become 3, and let's try and add a 4th, no problem. But if we try and add a 5th, it'll look like it's okay, but we can't actually place it. So because it says 4 out of 4, we can't do it. We can connect it anywhere else. And because they make no power, if we now go, let's say, and connect to our box here, and now we'll start generating power across all the lines. If we go and check this one over here, it'll also have the same information, and it's all updating correctly, except this one because it's not connected, obviously. So if we go here, let's try and connect this up to the bunch and see, it'll then start updating as well in real time compared to what it was before. And because this is right here, the value that we used, it doesn't matter that this one isn't updated compared to what the other ones are. So that does it. Thank you for watching this series. Thank you for watching this part. I hope you enjoyed. It was rather long, the whole series, but I hope you learned what you wanted to learn. And I will see you in the next video. The next video will be a bit special. It won't be about a tutorial, but more, let's say, a thanks and what's going to be happening next. So I will see you then. Goodbye.